Welcome. In this video, we're going to look at rate of change of a nonlinear function, and these ones are going to be from a table of values. So nonlinear functions are functions that do not have constant rates of change. We can find the average rate of change between any 2 points. Average rate of change will not be the same for any two pairs of points, and that is for nonlinear functions. As we know, only linear have a constant rate of change. All right, so we want to find the average rate of change from x equals 2 to x equals 6. All right, and so the 2 points are 2, 2, and so that's when x is 6, y is 2. And then the other point, when x is 6, y is 18. All right, so average rate of change. And we'll use, I'll just write it as change in y. So average rate of change will be the change in y over the change in x. All right, so we're going to take the difference in the y coordinates. And doesn't matter who I start with, but if I start with 18, all right, then I need to make sure that we start with 6 for the x, the difference in the x coordinates. So this would be 18 minus 2, difference in the y's there, and then 6 minus 2. And I'm just going to label that so that you can see the 2 points. So this one was x1, y1, and then 6, 18 was x2, y2. All right, so 18 minus 2 would be 16. 6 minus 2 would be 4, and so that reduces to 4. All right, so now let's find the average rate of change between 0 and 4. That's the other 2 points. All right, so 0, 0 will be x1, y1, and 4, 8 will be x2, y2. And the average rate of change is the change in the y over the change in the x. All right, so I'm going to start with the second point there. So we got 8 minus 0 over 4 minus 0. 8 minus 0 is 8, 4 minus 0 is 4, and see now we have an average rate of change of 2. All right, so this shows us that that table is from a nonlinear function. Because the average rate of change is not constant. And if it was constant, we'd get the same average rate of change no matter what 2 points we chose. And if we don't, then it's nonlinear. All right, so use the table to determine whether the minimum number of calories a tiger cub should eat is a linear function of its age in weeks. Right? So we want to find the average rate of change from 1 to 2 weeks. So average rate of change will be the change. This time, it's instead of writing it as y and x, right, because we have a real world situation here, let's write it as change in dependent over change in independent. Right? And so now which one is the independent, which one is the dependent? Right? So the age, time is generally independent, and the calories is the dependent. So how many calories the lion cub, so lion cub, right? Yeah, tiger cub, sorry, tiger cub. The minimum number of calories a tiger cub should eat depends on the age of the tiger cub. All right, so the change in dependent over the change in independent, so from 1 to 2 weeks, all right, and I'm going to take the difference from 2 weeks, so it's going to be I'm going to start with the larger point. That's what I'm trying to say. So the change in the dependent variable would be 1,000 minus 825 over 2 minus 1. So denominator is going to be just 1. And 800 minus 1,000 minus 825 is 175. So this is 175 calories per week, per age. I don't know what to call that units there. Let's just call it 175 calories. So that's the minimum number of calories it needs. I guess it's per week. We'll call it per week. All right, now let's try the next one. Find the average rate of change from 2 to 3 weeks. All right, so that's, again, the change in the dependent over change in the independent. All right, so now from 1 to 2, or from 2 to 3 would be 1,185 minus 1,000 divided by 3 minus 2. So that's 185 divided by 1. So now it's 185 calories per week. So now it needs more. He's a growing tiger. Find the average rate of change from 3 to 4 weeks. So average rate of change equals change in the dependent variable over change in the independent variable. Right, so 3 to 4, that would be 1320 minus, make sure we're having the right numbers here, 1185 divided by 4 minus 3. So it's 1 in the denominator. And 1320 minus 1185 is 135. So now he only needs 135 calories per week. Maybe he had a growth spurt between 2 and 3 weeks, and he needed more calories. And then finally, find the average rate of change from 4 to 5 weeks. So average rate of change equals change in the dependent variable over change in the independent variable. Right, so that would be 1420 minus 1320 divided by 5 minus 4. So that's 100 divided by 1. Or 100 calories per week. So now we have found all of the different average rates of change between each pair of consecutive weeks. All right, is this a linear function? All right, so this is not a linear function. And that's because it does not have a constant rate of change. Each week is different. If they're not all the same, then it's not a linear function. Okay? So it's pretty easy to figure out whether a function's linear or not linear by just taking the slope at different pairs of points. The table below defines the relationship y equals f of x. Use this table to compute the average rates of change below. Find the average rate of change of f with respect to x over 0, 4. All right, so this here is telling you that f of x depends on x. That's what that with respect to x means. So that means that the f of x here, which is the same as y, is the dependent variable, and the x is the independent variable. All right, so let's find the average rate of change from 0 to 4. All right, so that's going to be from this point to this point. All right, and we have change. Oops, I'm doing average rate of change here. Average rate of change equals, whoa, I don't know what happened to my R there. Ah, too much erasing. That equals the change in the dependent variable over the change in the independent variable All right, so we're working between these 2 points. All right, so the dependence at the bottom there. All right, so it doesn't really matter who you start with. I'll go left to right. So 26 minus 5 divided by 0 minus 4. All right, so 26 minus 5 would be 21 over 4. All right, now let's find the average rate of change from 2 to 5. So that would be from these two values. All right, so average rate of change is the change in the dependent divided by change in the independent. All right, so that would be 1. We're going between 2 and 5. So 1 minus 17. And, oh, you know what? I'm sorry. There's a mistake on the bottom there. 0 minus 4 is negative 4. So that should be negative 21 over 4. And you know what? I'm going to work left to right because I like the numbers better that way. So I'm going to go 17 to 1. So 17 minus 1. And I'm not going to forget, though, that 2 minus 5 is negative. All right, so that would be 16 divided by negative 3. Right, so or negative 16 thirds. So this is clearly not a linear function. The average rate of change is not constant. We can see here that negative 21 fourths does not equal negative 16 thirds, right? So not a linear function. And we also can see, because the numbers are getting smaller, so as x is getting larger, y is getting smaller. This is a decreasing function. And that just means y gets smaller as x gets larger. All right. So there we go. We found the average rate of change for two different points for this particular function. And that's where I'm going to stop. All right, so in the next video, we will look at finding average rate of change for nonlinear functions from graphs and from equations. And I'll start with graphs. Thanks for watching. Bye for now.